as we can. I'm hoping we'll get done with all of this today. Maybe we won't. If we don't, we're just going to finish tomorrow. Your homework is anything that you haven't done yet through 214. But this is us reviewing for our quiz. This is me reviewing each section. This first section is 211. In 211, all we did was we learned about all these algebra tiles. We just sort of looked at them. We investigated them. We looked at the sliders and watched which ones got bigger and smaller. The purpose of all of this is just to show that like each one of these tiles is a different shape, and each one is a different shape because it represents a different type of term. And the reason that they put them in different shapes is to show you that like ones are not the same as x's, and x's are not the same as x squareds. They're designed to show you that each term has a different meaning, they have a different value, and so you know, the tiles are named for their areas, and their areas are showing us that they like, because they have different areas, that they are not the same values. So that's the first part about the tiles, is just that there's different terms, and we're going to add them and subtract them, and we're going to play with these tiles. We can add things into the pile of tiles, or we can take things away from the pile of tiles, but ultimately we need to just understand what the terms are, that we have different terms, and they work together in very specific ways. So in order to help us visualize this, so it says note x and y are both unknown, but so like the x value here and the y value here are unknown, but that means they represent different amounts, like and they also so they're not necessarily the same. Like x can equal y, but it's usually not always equal to y, and it's usually referring to something else. We use different variables to represent different values in the problem. So if we have two unknown numbers, like, hey, go to the store and give me, bring me back $5 in cash, and then bring me 10 apples and 20 bananas, right? Like the price of apple is not the same as the price of banana, so we would use a different variable for each of those. And maybe they are the same price, but we're not going to assume they're the same price. If they are the same price, we're going to go, awesome, the value for the apple is the same as the value for the banana, but we don't know that yet. And also you'll never have different values for the variable in the same problem. So if x is equal to 10 in one problem, it will stay equal to 10 in that problem. There won't be another x that's equal to 3 for that same problem. But the value of x can change from one problem to the next. So if one problem has a value where x is 10, and another one later on, like further down the test, has one where x is 5, that's okay. Like x is not going to be 10 in all of the problems because of that. All right. So the important thing about the tiles in 211 is that they're not equal. One is not equal to 1x. 2x is not the same as x squared. X is not the same as y, right? And then like combinations of tiles aren't the same as other combinations of different tiles. So 2 plus 1x looks like this. And this is intended to show you that it's different from 2x. A lot of students think they're the same thing. Those students are wrong. A lot of students say, oh, 2 plus x is 2x. This proves that is inaccurate. And then there's a little bit, the opening part of combining like terms. So now we're talking about 211. First of all, this is sort of the end of what we needed from 211 right here. All this, everything to here is 211. Does anybody have any questions about any of this stuff? Questions? Am I going too fast? Is there anything you feel like you don't understand yet? All right. So moving on, if we have 5y tiles, we could say, like, this is combining like terms. If I have all of these, I can say 5y. 4x tiles is 4 times x, which means 4x. That's what 4x looks like. 2x squared looks like this. 3y squared looks like this. It means there's 3y squared tiles. 5y means 5 times y, looks like that. So that's the beginning of combining like terms. We can represent a pile of expressions in multiple ways. One is, so we can represent it as a pile of tiles as an expression like this. And if I was to make these connections, the reason that this is called 2y squared is because there are 2y squared squares. If I want, like, I can say, look, how many x squares are there? There's 1, 2, 3. And that is why we say 3x squared, because there's 3x squares. And so I can say, well, look, I got 4x's here. How do you know there's 4x's here? Well, there's 2 and 2 more. So there's where I see my 4x's. And then my 9 is right here. My 9 is these 3 down here plus these 6 make the 9. So the reason that we call it 2y squared is because it represents 2y squared tiles. And the reason that we call this 3x squared is because we have 3x squared tiles. And the reason that we call it 4x is because there are 4 x's. And the reason why we call it 9 is because there are 9 ones. So the other thing is, some students, they really struggle with understanding what we're talking about with expressions. The reason that we're going over this is to help you guys visualize this stuff, like help you think about how they're the same and how they're different and why that matters. Sometimes if you have an expression like this, it might be difficult for you to understand. It might actually be easier for you to think about if you do like switch these and make them, if you put them in like maybe writing them down, or at least visualizing in your head what the what the thing actually means. So if you guys are interested in that, it's certainly okay to write down, to draw a little diagram to help you think about it. And so, but this process is called combining like terms. Combining like terms allows you to take an expression that's very long and complicated and simplify it as much as possible. This collection of tiles right here, I could write it in a really long written out way like this: 1 plus x plus 1 plus x plus x plus 1 plus 1 plus 1 plus 1 plus 1 plus x plus 1 plus 1 plus 1. Right, with all those 1's and x's. I could do it like that. I could also like cluster these, like label them by their clusters. Like here's my 1, and then I have an x, and then I have a 1, but then here's a cluster of 2 x's, and I could say that's 2x, and 6, and x, and 4. I could say all of those things are the same. But then I could even take those clusters and I could multiply them more. So combining like terms is actually taking all 4 of these x's and just putting them together in one cluster. Doing this as much as you can. You can do it in phases where you go from this to this to this, but you should always be checking to see if you can combine more like terms. And then I can take the 1 and the other 1, which makes 2, plus these 6 here, which makes 8, plus these 4, and say, well, that makes 12, and just put those together there. And that will give me this full amount here, right? If I'm doing it without the algebra tiles, notice if I just zoom in here, just to this part, I'm going to erase this for a sec. Notice that if I just take this whole thing, right, I'm really just combining. I have the x and the 2x and the other x. If I was doing it with expressions and not drawing out the diagrams, I am just combining, taking all of the x's and putting them together, and then taking all of these 1's. I guess this was this one. Taking all of these 1's and bringing them all here. So the 4 plus the 6 is 10, plus 1 is 11, plus another one is 12, and that's where my answer comes from there. So that's called combining like terms. The first thing that we needed to understand in 211 is that we have different terms and they have different meanings. What I want you to get out of 212 is just that you can take the terms that are similar and you can combine them into one simpler term. Like I can say I have x plus 2x plus x, and then, or I can say I have 4x. I can say, look, I have pen plus pen plus pen plus pen, or I can say I have 4 pens, right? There's different ways of saying things. One of them just makes more linguistical sense. So which expression is simpler between these ones? These are just the 3 expressions that we had written above, and this one is less writing. It's easier to think about. I still know what it means. It's very descriptive. But a warning is that you cannot combine unlike terms. So this is a warning. I have students every year that try to combine unlike terms. It's important to recognize the terms, if they don't have the exact same, what I like to say, last name. If the last name isn't the exact same, then you can't combine them. So every year I have students, I guarantee you I'm talking to some students right now that are going to get this wrong, who look at this and go, well, that's a Y and that's a Y, so they must be the same term. But these are not like terms. One of them is not, they're not both Y. One of them is Y squared. And I can tell by the shape of the tiles that they're not the same. So 1Y plus 2Y cannot be simplified because it has different terms. The most I could do was just combine this X and this X to make, or sorry, those aren't X's, those are Y's. Combine this Y and this Y to make 2Y. That's all of the simplifying I can do here, and that's okay. A lot of students go, but I got to be able to do more. I got to be able to do more. You don't. You don't have to. A lot of students think that 1Y squared plus 2Y equals, they will tell me, well, that equals 3Y. This is what 3Y looks like. That is not the same as this. They are not the same. Or some students will say, oh, well, it equals 3Y squared. This is what 3Y squared looks like. This is not the same. So the only correct answer here is that one. 1Y squared plus 2Y, that's it. And that's all there is to know about combining like terms. We went over these notes earlier, so I don't want to spend as much time on them, but I do want to know, I would like to see your blue hand if you feel like this is making sense. So I'm going to lower your hands. Please let me know if you feel like this is all 100% crystal clear to you right now.